Hi, good afternoon. My name is Warner Blumenthal. Thank you very much for joining us this afternoon for our 3D Printing 101 webinar. I see there's a couple of repeat customers, so it looks like we did our job last week. So thanks for coming back for those of you that came back, and then also welcome to the new faces that we see. So this is our second segment of, I believe it's six-part series where we're going to be covering from a very high level, then kind of anchoring down to specifics about the certain vertical technologies that we offer as resellers. In general today, what we're going to be doing is giving you a very high level view of the most commonly available 3D printing technologies, the ones that are already commercially available. We are going to be leaving out some of the outliers like bioprinting, things like that, but we're going to be covering the ones where you can actually actively go to an established company and purchase a printer or use it as a service, right? So let me get into this. Okay, so the agenda for today is first off an introduction. We're going to be talking a little bit about WB Engineering, which is our company. We're going to be talking a little bit about 3D Systems, which is the partner we have with 3D printing. Again, we're going to be talking about all different types of technology, so we're going to try to keep this as general and as unbiased as possible, just so you guys can get a good idea of what each technology has to offer. And then we can obviously talk about the specific printers later on in another webinar. But again, right now what we're going to be doing is talking about in general what each technology has, the highlights and the limitations of each one. So we're going to try to look at this more from a user standpoint as opposed to a vendor standpoint. So we're going to go into an introduction of 3D printing, and then we're going to go very, very high level description of plastic jet printing, color jet printing, multi-jet printing, stereolithography, selective laser sintering, and then direct metal printing. Also, before I forget, feel free to go ahead and, whoops, sorry about that. Feel free to go ahead and ask questions. If you want to ask questions, we will answer them as we go. So don't forget to go ahead and ask questions in the dialog box. Okay, WB Engineering. So WB Engineering is a product development and design company. We focus on medical devices, consumer products, aerospace, and we use 3D printing on a day-to-day basis to help facilitate that process for us. So we're going to be talking to you more so as a 3D printing user as opposed to a 3D printing vendor. So we understand a lot of the issues that happen along the design cycle for a lot of or a wide variety of industries. We've been working for almost the past decade in product development. We've worked in a wide variety of applications and industries. Therefore, we know a lot of the pains. I'm not going to say that we know all the pain, but we know a lot of the pain that goes along with product development cycle. And we'll kind of point out how we've used 3D printing and the limitations that we've found with 3D printing, and then also how 3D printing has really helped us out significantly. So we're, in addition to a product development company, we are a partner with 3D Systems. We've been a partner with them since 2007, and then we're also an Autodesk partner. So we sell Autodesk software, and we also offer training for Autodesk. So 3D Systems, you don't need to really necessarily read the couple paragraphs I have here, but in general, 3D Systems invented the technology almost 30 years ago or so. SLA was the initial technology that created the entire industry. They've been developing their portfolio since then. They have a wide variety of technologies, the widest available. And they also are building up a portfolio of products and services around just 3D printing. So recently, 3D Systems has gotten into software, into simulation, into virtual surgical planning, medical and dental devices, surgical instruments, etc. They are focusing on developing 3D printing into the future of manufacturing, right? So the reason why we chose to go with 3D Systems as opposed to a lot of the other vendors that are out there is because 3D Systems dedicates a significant amount of their revenue to R&D, and they have a very, very wide portfolio of technologies, which gives us the ability to offer to our customers what they need as opposed to what we need them to need, if you know what I mean. So we don't just have a hammer, we have a hammer, a screw, a saw, etc. So we like to think that we try to give you the tools that you actually need, not the ones that we have to offer, right? So, and also I would be quick to say myself that if it's a printer that we don't have and it doesn't fit your application, we're going to try to make sure that we don't shove it down your throat. So a little bit about 3D printing's history again. Chuck Hull invents SLA, then they invented SLS. They also invented color jet printing. Now I'll put a little asterisk next to that one. Color jet printing was actually invented by Z Corp, which was then purchased by 3D Systems. So therefore, via acquisition, they did invent color jet printing. The next one is they invented multi-jet printing. I know another industry term out there is polyjet printing. 3D Systems invented multi-jet printing back in 1996. And then 3D Systems introduced PJP, which is plastic jet printing, which another industry term is fused deposition modeling. So they didn't invent that, they just started offering their own version of it in 2011. So these are the main vertical areas where 3D printing is currently being used, right? So 3D printing, and again, there are other applications for 3D printing. This is a just very general categorization of what 3D printing is currently being used for. So communication, that's one of them, right? So it's always easiest to communicate something to somebody via giving them the product that you're actually talking about, right? We use Autodesk software here. We do all different types of animations, renderings, things like that, but this never ever matches up to actually handing the part to somebody so they can look at it in their own hands, feel it, see how big it is, etc. The next vertical that's very, very common is functional prototypes. So that falls into the whole validation area. Is this part the size it needs to be? Does it fit? Does it work the way it needs to work, etc. So there's certain requirements that your part has to have in order for you to actually be able to validate your part and make sure that it is actually what you do need before you go to production. The next one, which is one that's actually caused a lot of buzz recently, is since we've been able to develop a wider portfolio of materials, specifically high temperature materials, now pre-production is possible, right? So you can actually injection mold parts using 3D printed molds. So this is something that helps bridge the gap significantly when we run up with a lot of situations where we're designing something for a customer or even trying to sell a printer into a customer. They say, wow, that printer is great and everything, but my product has to be specifically in this plastic material because it requires X mechanical properties. And then our answer before was, well, we have this material that's polypropylene-like or ABS-like, etc. Now you can actually, instead of saying like, you can get exactly the mechanical properties that you want. So therefore, the process in that situation would be 3D printing a mold and then injection molding it with the exact material that you want. Therefore, you get a one-to-one representation of what you're going to get when you go to production. That is, needless to say, extremely valuable. Not only because there's really no guesswork involved there, it's literally the part that you're going to get when you go to production, so it's actually pretty useful. The next one, which is actually causing a lot of buzz as well, is production, right? So the larger printers are actually getting to the point where in certain niche markets you can actually go to production with a part directly off of a printer. Or furthermore, you can use a 3D printer to produce a tool to go straight to production, right? So you can cut out the middleman in terms of CNC machining, etc. The next one is mass customization. This is another big market, right? So I I actually use a product that's mass production and mass customization, my Invisaligns. The Invisaligns that are used by, I think at this point, well over 1 million people are all produced using 3D printing, right? So the actual part you put inside your mouth isn't the 3D printed version. It's actually the part made via a 3D printed mold off of one of our printers. So it's pretty interesting there. So now, I want to start off with our first poll here. We're trying to be as user-friendly as possible with our attendees. So I want to actually see if we can see what the best time is for you guys to attend our webinar. So if you guys can take the opportunity and actually help us out with this, that way we can actually time these webinars better. That way you guys have to rearrange less things, and we can get the information to you as efficiently as possible. Okay, we're just waiting for a couple more people to vote. Okay, thank you very much for saying that. Looks like the majority of us prefer these in the morning. We will see if we can accommodate that moving forward. Okay, so let's get into our first technology here, right? So first one is plastic jet printing. This is more commonly known as fused deposition modeling. This type of technology, the applications in general form is rough conceptual models, low resolution applications. We've seen this be extremely successful in education applications. They produce low-cost prototypes, and you can also produce jigs and fixtures. I added an asterisk there. You'll probably see a few asterisks throughout the presentation. It's basically to cue me to clarify that a little bit, right? So with jigs and fixtures, and you can do jigs and fixtures with the technology. Why? Because they're, the robust parts that you can get off of these, but low fidelity, right? So I don't want you to think that you guys can produce a very high tolerance jig and fixture right off of a printer. You can then, maybe sand it down or machine it down to get it more precise, but right off of the printer, beware, these parts aren't extremely accurate. So how does PJP or FDM, fused deposition modeling, work? I also want to point out, every time I get to one of these slides on the bottom, we'll have definition of the industry terms. I'll be saying a lot of acronyms. We try to define the main ones on the bottom. That way, you guys can, just reference back to that every once in a while. So this is what a wide variety, or majority, of our customers have come in contact with or seen firsthand. These would include the MakerBots, the Cubes, the Delta makers. I mean, there's literally, I think at this point, with no exaggeration, hundreds of manufacturers of this type of technology. They have their niche, right? So in general terms, the way plastic jet printing works is it gets a spool of a plastic and then extrudes it through a heated nozzle. The number of nozzles vary depending on the manufacturer or model that you choose. I've seen as many as 3 extruders. There could be some models with more. I'm not sure. The market's so large now that it's hard to keep up. And it can also produce prints with multiple materials. So what's the benefit of that, right? So the benefit of being able to do things with multiple materials is that it opens up the door to multiple supports and or just multiple material properties in one part. The amount of printers that can actually produce multiple materials in one print in this realm is not as popular as the ones that just print one material across the board, but it is available. And again, the benefits are, more than anything, is really soluble supports, and then in other cases, multiple material properties, but those are a little bit of a niche. So highlights of this: low bar to entry, right? So you can find some of these printers on the market sub $1,000, in some cases sub $500 when you get into kits that you can build yourself. So therefore, it's good introductory technology. I don't recommend it for engineering type applications or high precision type applications, but definitely to get some kind of rough proof of concept of a rigid printed part. This is definitely good. It's inexpensive prototypes off of the consumer level ones, right? So there are professional level plastic jet printing solutions out there. They do produce slightly higher resolution parts, but again, this is not the technology that you go to for extreme high resolution. They do vary, right? So you do have the consumer level and the production or professional level ones, but again, even when you get into the production or professional level ones, it's not the technology you go to for high resolution. It could be the technology you go to for just rigid parts that can handle some stresses. So limitations, again, accuracy and tolerances. We use this technology in-house all the time. I'm not saying not to use it, but we know its limitations, right? So we always have to anticipate if we're doing an ID on a part or an internal diameter of a hole, we know it's going to be undersized on this. Also, there's a significant amount of warpage that happens on these parts when you do print out large cross-sectional areas. They do tend to delaminate from the build plates, and again, I'm sounding like a bad salesman, but I'd rather you guys get the entire gist of the products via a webinar as opposed to after you already made the investment, right? So there's limitations to this technology in general. The support material, right? So there are materials that are soluble. It's not what I had anticipated initially as soluble. It does take a while for this material to actually dissolve. So yeah, you do need a bath overnight typically. And if it's not soluble supports, it's breakaway, which can damage the part significantly and or be very laborious. It takes a while to break away that support. It's kind of rigid. The part detail and geometry is limited, so you have to really learn how to orient these parts in order to get very good feature quality out of it. So there's a significant learning curve on printing and orienting these parts, right? So you can't anticipate to get a printer in this technology, orient your part however you want it to, and then expect a perfect part to come out. So you have to kind of work with the technology to get good parts. So there's a little bit of a learning curve here. Like I said, the post-processing is laborious. Speed, I put an asterisk next to that. Why? Because if you print one part on this and you compare it to other technologies, it might hold its weight, right? So you can print out one part, let's say it's 4 hours, and you print it out on another technology. Maybe the other technology takes 8, right? But then when you get that same part, you multiply it by 2, it doubles the time, and then you put a third part on there, triples the time, right? So the speed on this is only really good when you're just doing one part. You don't want to submit multiple parts to this printer. It's just going to be additive. You're not going to get any speed benefits off of this type of printer. So that's a little bit of the issue there with this one. So the printer that's offered by 3D Systems is a Cube Pro. We use this on a regular basis for quick and dirty prototypes. Education loves this technology. So you can produce some pretty rigid, nice parts off of this printer. Very entry-level price point. There are tons of manufacturers that make this. Obviously, I'm going to be partial towards the Cube Pro just because I feel like it's well built. I'm not going to lie to you and say it's the most affordable out there because there are other options, right? All right, next poll. So we want to continue digging in, seeing how we can continue getting this good attendance, and we want to see what's the best day of the week for people to actually attend these webinars. We have our own internal assumptions, but we'd like to hear from everybody else to see when is the best time for people to actually attend. We actually have an internal bet going, so I'm hoping that I win. My assumption is Friday. So we're just waiting for a couple more people to answer, and we will be on our way. Okay. Thank you, everybody. So it looks like Tuesday is the least favorite, but we had a pretty even spread across the board on the rest of them. Okay, so the next one, color jet printing. So color jet printing is actually, I think, a very impressive technology. It makes beautiful, beautiful parts. It has a wider range of applications than our color jet printing, different applications though, right? What you do with plastic jet printing and what you do with color jet printing are going to be completely different applications. With color jet printing, you can do very good communication models. You can do very nice scale models, industrial design, ergonomics, sales tools. We've seen this actually work out extremely well in educational markets, architectural, museums, being that they scan things and then actually 3D print them, like dinosaurs, different types of parts that they want to put on display. There's actually even amusement parks that use this for different small fixtures, etc. This has also been used in movies, and now there's a big market right now of companies creating the 3D selfie, right? So there's people scanning people and then 3D printing portraits of them. How does this technology work? So this is now a little bit more elaborate machinery, right? So as big difference between what we saw in plastic jet printing to this is that now the price point on these machines are a little bit higher. Why? Because they're a little bit more involved machines. With the color jet printing, basics are is that you're going to get a base material, which is going to be gypsum. The good thing is that you can get CMYK coloring, so that is cyan, magenta, yellow, and black. So you can actually get 600 plus colors out of one of these printers. It actually uses a liquid binder to bind the material together. It has multiple print heads like a 2D printer does. Actually, our ProJet X60 line uses HP print heads inside of the printer. And then also it's very, very efficient in printing large parts. So a couple key takeaways from this technology is you can print extremely large parts, and unlike with plastic jet printing, where all the support material is actually wasted, in this scenario it's actually completely recycled, right? So when you actually print a part out here, anything that would have been supported in plastic jet printing can actually be vacuumed up and then recycled back into the machine. In this scenario, as you see in the schematic, what we have is we have two vats, right? The orientation of these are slightly different than what the actual machines have, but the gist of it is the same. We have a build area where we have a powder inside of the bed. It has a piston underneath it where the piston actually starts dropping as the layers keep going. And each layer is actually generated by an inkjet printhead. The printhead actually includes binder, which is a liquid that binds the plastic or acrylate or gypsum material together. And then it actually simultaneously jets in ink or color. So it doesn't fully color the entire cross-sectional area. It actually just colors in about 1 millimeter to 1.5 millimeters of the periphery of the part, right? So you're not wasting a bunch on the inside of the part. It's only coloring the exterior of the part, the visual part, right? So it's very, very highly efficient machine. Good thing about this is that you can actually produce very large parts very inexpensively. The other thing is it does have a print head that has a certain width to it. Varies depending on model, but the good thing about it is now you can start getting a little bit of economy of scale or better turnaround on these parts, right? So let's say one part takes you an hour, 2 parts might take you 1 hour 20. It's not completely a multiple like with plastic jet printing, so you can actually start to get some pretty fast turnarounds. Also, this is one of our fastest technologies there is. So if you want to do large, inexpensive parts with color, this is the technology you want to look at. It's very, very efficient. So what are some of the highlights? Well, I already mentioned some of them, but let's go over it again. Full color capability, so you have CMYK coloring. These are some of the examples of things that you can produce on this printer. You have affordable large prints. Like I mentioned, you can actually recycle all of the support material back into the machine, so there's no waste. Fast printing times. You can print out large parts, even large builds, full volume builds overnight, not multiple days, just even from morning to afternoon. It's office friendly. Now I put an asterisk next to that because I want to be real with everybody. This is a powder-based printer, right? It's only as office friendly as the user is. I do have some clients that have this in an office. They keep it extremely clean and it is good to go. I do have other clients that are less diligent than others, and I would not say it's an office-friendly machine when you use it that way, right? So it's completely dependent on how the user uses this printer. It could get messy very quickly, but if you treat it like the capital equipment that it actually is, it actually can be in an office environment without any types of issues, right? So what are the limitations of ColorJet printing? Well, one, which I failed to point out here, is that the parts are rigid. You're talking about something that's going to give you the material property of like a ceramic, right? So it's not going to have any pliability whatsoever. They're very, very tough parts, but you're not going to get any flex at all. That's one of the things I forgot to list as a limitation. The next thing is post-processing can be laborious, right? So again, I want to be completely honest and upfront with everybody. These printers are not as easy to work with as one of or a couple of the other printers we'll be talking about later on. So I would say if we're talking about most laborious to least laborious in terms of professional printers, this would be closer to the higher laborious ones. I know the other salespeople might be frowning right now as I say that, but I just want to be 100% honest. I was spoiled with the next technology that we're talking about, and then when 3D Systems purchased Z-Corp, we got one of these printers in-house. I was actually surprised how much work has to go into it. I don't want to scare you away. It's not something that is going to be you know, more laborious than actually creating one of these models by hand or any other methodology. I'm just saying in comparison to other technologies, this would be the more laborious one. So the process, just to be clear, is you end up with a, let me go back a slide actually, you end up with a vat full of this powder, and then you actually have to excavate your part out. So depending on what model you purchase, you can either automatically evacuate the build volume via an automated process that some of the printers come with, but then you actually have to then brush off the part, airbrush the part, and then it's optional but almost always required. You have to infiltrate the part, so you actually have to then dip this in a cyanoacrylate to get it really, really hard, which they call color bond. So it's a process that has to go on. The other thing that I want to point out is that the user actually has to maintain this printer between prints, which I say this just to make it 100% clear, right? If you look at any of the competing printers, you also have to maintain every single time that you print, and even some of our printers, including this one, right? I'm just, again, I'm spoiled with the with another technology I'm about to talk to, so I have to note this because I didn't anticipate this even as a reseller looking at sales presentations, how much added effort was going to have to go into this. So after you use this printer, you do have to put in about 15 minutes of maintenance in between prints. So it's not just simply ready to go, ready to print. You actually have somebody who you have trained, not a full-time employee, just somebody who knows what they're doing, to clean the machine, get it ready to print again. It's only about 15 minutes, but again, I want to make sure that everybody is well aware of that. So to sum it up, great to produce full color parts, very inexpensive, fast printer. You do have to take a little bit of time post-processing the parts, but all in all, it's very, very good printer for large, nice cosmetic parts. So this is our CJP X60 series of printers. We range from monochrome all the way to full CMYK colors. Some of them do come with a cleaning station attached to it. Some have it as an accessory. But long story short is if you want really, really bright, vibrant color parts, large parts that are inexpensive, this is a technology you want to look at. So again, just keep you guys engaged here. We want to continue asking to learn a little bit from our audience. So again, I apologize for the people that were here last week. The rest of these questions are going to be relatively repetitive. So we want to know, do you currently use 3D printing? All right, we just wait a couple more minutes for the last few people to answer. Not a couple more minutes, I'm sorry, a couple more seconds. Okay, just a couple more left. Okay, I think we almost got everybody. I think maybe a couple people I might have put them to sleep, so I apologize for that. Okay, so moving on. So it looks like the majority of the people on this webinar have not actually used 3D printing, which is good. So this is a good warm-up for you guys. So now this is a technology I've been raving about, right? So this is the one I, as a reseller, first signed on with using. I got to admit, at the beginning when I first started using this technology, it was a little bit cumbersome in terms of reliability, but it's been tested and proven since then. So I can say with a straight face nowadays, this is a very, very reliable technology, and the printers are extremely robust. What are the applications? The applications for MJP, which is multi-jet printing, and that'll be detailed on the next slide. Conceptual design, right? So you can do conceptual models, you can do engineering, validation, and verification. So these parts are precise enough for you to actually hold the caliper to and make sure that it is a spot-on part. Not to mention, you can do fit testing with this, so you can actually get the part, make sure that it is the exact geometry that you need before you go to production. So pre-production samples can be produced on this, right? So if anybody is in manufacturing on this webinar, you know how costly in terms of not only time but money it is to find out that you made a mistake after you already made the mold. So with this technology, you can get a one-to-one part before you go to fabricating or manufacturing without having to wait for a CNC machine to become available, and also not having to worry about complexity. So the complexity is free on these parts. You don't have to worry about how complex the parts are. 3D printing can accomplish it. The only thing you have to look at is this part volume, right? The next thing is you can actually use these parts for injection molding. So you can actually create a mold off one of these printers, then inject mold it with the specific material that you need. Communication, just like the other ones, high tolerance and high accuracy applications. So this is a real engineering tool. You can actually use these with a high level of confidence to produce parts that you need to have a high level of accuracy for. Fit test, jigs and fixtures. Notice there's no asterisk on the end of that because this can produce extremely precise jigs and fixtures. We have Class 6 biocompatible applications, so therefore you could use this for surgical guides. You can use it for things that are going to be coming in contact with people during surgical procedures. So it actually starts widening up the range of applications. Furthermore, casting is another huge application for multi-jet printing. You can actually get a part directly off of these printers, be it off of one of our acrylate printers, and then you burn it out, or you can do it off of one of our direct wax printers and just melt it out just like you do with traditional casting processes. That's a good way to get to metal printing without actually having to take on the capital investment that is required with a direct metal printer. So this is a good intermediary where you can actually cast the parts off of your printer without having to go through a significant learning curve, because I know there are some casting companies out there that are very, very talented at casting almost any material. This material is catered to being cast, and cast with a very high level of precision and a very, very negligible ash content. The other thing is you can do things with ergonomics, obviously. I like to tell a quick story of our first 3D printer that we sold was actually to a orthopedic surgery company. They had a doctor that was going to show up the next day in order to evaluate the product that they were designing. They actually asked for a benchmark part from us. It just so happens it was the part that the doctor was going to come see. It turns out they actually sold more units than the printer was worth just off of the benchmark part. Why? Because the customer was actually able to hold the product in their hand, go over a design review, and sign off on the purchase of a large quantity of this product that was actually still in the prototyping phase. So I like mentioning that one just because that kind of application goes and shows how this works. Actually, there is somebody here that did point out a mistake that I had here. I'm sorry, it's Class 6 biocompatible, not Class 4. So I appreciate your attentiveness. I apologize. Yeah, so that is Class 6 biocompatible, not Class 4. So thank you for pointing that out. You can also do snap fits. So that's another benefit of this. So unlike with the color jet printing that is no flex whatsoever, this actually you can get some flex out of parts and you can print multiple materials at the same time. So how does this work in difference or in contrast to our color jet printing technology? So you'll notice it's kind of an extrusion-based technology like the plastic jet printing, except for, I like to say, on steroids. So where with plastic jet printing was just 1, 2, maybe 3 extruders at a time, we're talking about over 600 jets that eject material out of this machine. The print heads on these printers are actually extremely wide as well, so that gives you the economy of scale kind of benefit that you get with having multiple points of material, because if you have one part, let's say it takes you 4 hours to print, you can actually fill up the entire build plate of the same exact part, whether it be, you know, you can fit 100 of them on there, or whether you can only fit 4 of them on there. You know, let's say that, you know, that one part was going to take you 4 hours, the entire build volume will probably take you maybe 5 hours. So it's a small percentage increase in terms of amount of time required to print a part. What dictates speed and time on these multi-jet printers is Z height. So you always want to orient these in the most low orientation possible so that you can actually maximize your build speed. The other thing is, just like all other 3D printers, you can submit a potpourri of parts. It doesn't have to be the same exact part. So how does this work? So in this scenario, there's 2 different types of movements that we have in these printers. With our ProJet 3600 line, actually the build plate is the one that moves back and forth in a lateral, let's just call it in the X direction, and then the print head actually moves in the Z direction. So the part moves back and forth underneath the print head. The way this works is it actually prints out, in some cases, 2 material, in other cases multiple materials, and you can actually mix them at the same time. But essentially what it does is it actually jets out liquid material which sprays down onto the build plate. Once on the build plate, it actually gets UV cured by a UV lamp inside of there. So there's what we call phase change material for a couple reasons. One is it goes from solid to liquid in the print head, and then back to solid on the print on the build plate. Our material, in contrast to the competitors, actually solidifies immediately, even before the UV light hits it, because it is a semi-solid, even in the green state. It allows us to get extremely, extremely sharp edges. Also, this does extremely high resolution, so you can do very, very sharp edges, very small pinholes, very complex geometry, and it does it extremely quickly. The support removal on this is, just to say it as best as I can, awesome. The material on this is actually something that you can melt away extremely easily. So just to summarize how this works is, again, it jets down onto a build plate, and then it starts adding layer by layer, one on top of the other, to then start building the part up vertically, laying down a wax support material as it goes. So what are the benefits? So you can get actually better than injection molded part accuracy, right? So you can actually hold the caliper to these parts and they are going to hold up. It's about plus or minus a thousandth of an inch per inch of build, which is pretty nice. Then you can also you get injection molded finishes. You have castable materials that are available. You have near limitless geometry for producing parts. That is, I say nearly limitless because, you know, currently right now we can get down to, in some geometries, down to like a 1/4 millimeter wall thickness on like high-res filters. That's our current limitation, right? So there are some limitations to this, but I've seen this solve 90+% of my customers' geometry challenges. The only times that we've had something that can't print in terms of really extremely high detail are when you get into extremely high resolution filters. And even in that case, this is the best go-to technology for that kind of stuff. The next thing is post-processing is not laborious nor time-consuming. So this is why I seemed like I sounded so harsh with the color jet printing. It's because I was used to the post-processing involved with this printer, which is simply grab the part off of the printer, throw it inside of a temperature-controlled lab oven, and then you just come back, 20 minutes later and your part's clean. So it's hands-free, hands off. You don't have to worry about it. Also, the printer is basically self-maintaining, right? So as soon as I take my build plate off, I can load another build plate on. The build plate's reusable, but it comes with 2 build plates. You just swap it out real quick and get your printer up and running again. So there's no cleaning process that the user has to do. The actual printer does its own cleaning process. So you get really high throughput on this, and it's extremely easy to maintain. There's really no learning curve here. So you can orient the parts as you wish. The parts are going to come out with the same precision and the same part quality as you can imagine. You don't have to worry about how you orient them. Limitations, so non-reusable support material. So the wax material that you actually melt off is something that is consumable. That could turn into something that you want to look into, especially if you're looking at this printer to produce extremely large parts. When you start printing really large parts on multi-jet printing or even the competing technology, polyjet printing, you are going to get a large percentage of waste compared to our other technologies. So therefore your part cost, you need to actually start factoring in how much support material is going to be going into your part when you look at this technology. So across the board, this is going to give you the best resolution in the entry-level professional era or spectrum of printers, but be wary. You want to make sure that you always pay attention to the supports that you're going to be using here and factor that into your costing and your budgeting when you do that. Where with color jet printing, support gets completely recycled. In this scenario, it does not. So it's not the best to get economical large parts out of. Now, you can print large parts, and I do have customers that do that on a regular basis, but I always make sure they factor in the cost of the support material into this, because that will start to add up. The other thing that I put here is printing capabilities can get you into trouble. Why? Well, because it can print literally anything almost, right? So just because it can print it doesn't mean it's manufacturable. So I just want you to note that now we're getting into the realm of 3D printers that can produce things that just aren't practical or feasible to manufacture. So if you do have some rookie engineers that are going to be learning on one of these printers, make sure that you reel them in, because they might start printing some stuff that is just not practical to make for long-term manufacturing. So I just wanted to put that there, just because we've experienced that internally. Okay, so our multi-jet printing series of printers ranges from the newest one that just came out, which is the ProJet 2500. That one is selling like hotcakes right now, just because it offers basically the same surface quality and precision as our higher end printers do, but at a fraction of the cost. It can also do flexible materials and rigid materials, and then it goes all the way up to our 5500X that can actually do a wide range of materials via mixing rigid and flexible materials, and also has a large build volume as well. So this is, if you're an engineering company, product development company, plastic injection molding, and you have a decent amount of throughput, your parts are medium to small in size, this is the line of printers you want to look at. You're not going to get better part quality at that price point, and it's an extremely, extremely useful engineering tool. We use it all the time. It allows us to compete with larger, more established engineering firms, and we actually are able to win Fortune 100 contracts to develop their products. Why? Because we're able to leverage this technology to not only produce high quality products, but we're able to optimize and find our mistakes faster than the next guy is able to just produce their first prototype, right? So it helps us definitely learn internally, optimize internally, review with our customers, and move on to the next iteration extremely quickly with a high level of confidence that these parts are accurate and precise to what the manufactured version is going to be. So this is a real engineering tool. I swear by it. I honestly give a lot of credit to the success of our company to having access to this kind of technology. So engineering, plastic and electrical enclosures, those are no-brainers for this kind of technology. Take a good hard look at multi-jet printing for that. So I do have another poll. So are you currently looking into 3D printing? Let's go. Let's see how many people are actually looking into 3D printing, and in what time frame? So while you guys answer that, I just want to fill you in. So I am giving a very high-level introduction to all of these technologies. We will be getting much more in depth into each one of these technologies in the coming weeks. I'll give you guys the dates for those towards the end of this webinar. We will get into a lot of the intricate details of each one of them and dive a little bit deeper into the types of capabilities each one has. So thank you very much, you guys. I appreciate it. I'm going to now move on to our next technology. So now we've moved from what 3D Systems considers professional printers into now production printers. Why? Well, because they're just more capable. They're built even more robust than the professional ones, as if that's even possible, but they are considered industrial equipment, right? These now are not considered to be office-friendly printers. So if you're going to be looking at SLA, SLS, or DMP, which we'll be getting into shortly, make sure that you have a facility to house these printers. They are considered industrial equipment, so if you have a machine shop, perfect, you're good to go. If you're in a third, fourth floor of an office building, you probably want to just continue looking at multi-jet printing or the other options we already spoke about, because these do have facility requirements. That's a little asterisk I want to get into before you get excited about the parts that it can actually produce. So what are the applications here? Prototype, end-use parts, medical models, casting, rapid tooling, injection molding, cast urethane, jigs fixtures, high precision validation verification, bridge manufacturing, large parts. So we actually have a customer that we just sold one of our larger SLA systems to. They are actually printing injection molds directly off of their SLA system, large ones on top of that, not just small little molds. And they are doing thousands of parts off of those molds. Why? Because it's very highly customized, short-run manufacturing parts that they make in a very niche market. So in their scenario, SLA was the way to go. They make molds and they injection mold them with the specific material, and they can actually get a decent cycle out of their molds. Once it starts wearing down, they just print out another one. So basics of SLA, the technology in general. So this is now a liquid resin, so it's actually a vat full of a photocurable material. The build plate actually moves vertically downwards into the liquid vat. What turns the liquid into a solid is actually a laser beam. So the laser beam actually scans the cross-sectional area, and then a sweeper comes over to add a little bit more liquid resin over the top and make sure everything's nice and even, pops it out. So let me explain the difference between this and what you'll see in a consumer level 3D printer is for example, the Formlabs, another printer we use here in-house, great little printer for quick and dirty type prototypes. It actually inverts your part and fights against gravity to hold the part to the build plate. Well, what does that do? That causes some warpage. It also causes for the support material to actually be pretty thick and causes some blemishes on the part. For the price point, the Formlabs is a great little printer, but we cannot use that for engineering validation or verification, nor do we use it for that. With production SLA printers, you have a neutrally buoyant part inside of the build vat, so therefore the support material is significantly less damaging to the part. We would consider this wipe away material or wipe away support as opposed to breakaway support. Main difference there is that you're going to have much higher precision on all sides of your part. You're not going to have huge blemishes on the part. You're not going to have to do a significant amount of sanding, sandblasting, or anything like that. Literally, the parts come off the printer almost ready to go. You just have to snap off a couple things, and the post-processing is extremely easy in comparison to what the Formlabs would be. I say that firsthand just because we have a Formlabs. It's a great little printer. If you're looking at an entry-level printer that does good resolution, Formlabs all the way. But if you're looking for something that's for pre-production, real, engineering, manufacturing type applications, you want to look at SLA because now you have much more robust material offering. You have high efficiency support, so now you can get into big parts that aren't going to cost you an arm and a leg because it's extremely efficient with the support material. And you have industrial grade equipment. This is stuff that you can run day in and day out and produce hundreds of thousands of parts. This is actually the type of printer that the Invisalign runs its entire business line off of. So it's very good to know that this is something that is built tough and lasts long. So SLA is stereolithography. So high points, high precision parts, the highest precision that you can get out of 3D printing, period, right? You have a broad range of materials, so just a cross-sectional view on the right, you notice the top right one is actually an engine block. I like pointing that one out because that's actually printed in a mold called Quick Cast, which actually produces a honeycomb interior, and then that facilitates the casting process much better. We have high temperature materials, which you can use for injection molds, or even just high temperature and use parts, castable. You have high throughput. You can produce clear parts, you have biocompatible materials, and there's a bunch more other highlights. The next thing is limitations. Industrial grade machinery. It's not office friendly. You do need facilities requirements for this. Also, it is capital investment, which requires a significant, above six-figure budget for this type of a printer. But if it's something that your company needs, those 6 figures will be justified extremely easily. You just have to know how to use your printers efficiently. This is a line of SLA printers ranging from the ProJet 6000 all the way up to the ProX 950. So really the only difference between these are a couple resolution differences, and primarily the biggest difference is build volume. So if you need bigger parts, you start getting further to the right. If you need just high resolution prints, then all the way to the left. So last question, and then we're going to be moving on to SLS. So the question is, how would you be using 3D printing? Would you be using it for prototypes, end-use products, casting, marketing and sales, or others, right? We have a lot of applications that we've actually found out about because our customers are just creative with how they're using 3D printing. Okay, I'm going to wait a couple more seconds because I know I'm starting to run low on time. I want to start speeding things up just a tad bit. And I'm going to move forward. I almost got everybody answered, so thank you very much. Looks like we have a pretty even spectrum of answers. So now let's get into SLS, selective laser sintering. So this stuff is actually really cool. The last two technologies I'm going to talk about are actually very, very impressive. So these SLS printers, you can produce end-use parts. This is really, honestly, the main application for this type of printer. You want something that you can throw against the wall, run over with a car, beat up. The SLS is what you want to look at. These are parts that they've used for crash test dummy applications. New Balance is actually doing a full customized line of shoes that they will actually be doing the sole, which is a honeycomb kind of, or a porous spongy kind of sole that you see on this shoe in the picture. That's going to be pure 3D printed and an end-use product. Then you have these drones. There's actually a sunglass line that uses SLS prints right off of the printer to produce the sunglasses they sell directly to customers. So functional prototypes is a no-brainer with this. Living hinges, this is the only technology that you can actually do living hinges on. The other ones you can move a certain amount, but you'll cycle through it a few times and the part will fatigue on you. This stuff is end-use grade, so you can actually do living hinges that you can cycle through hundreds of times and not have to worry about it breaking. Jigs and fixtures, and you have the broadest range of materials available in terms of SLS technologies. 3D Systems has it. So this is very, very similar to SLA, and so it's kind of a hybridized version between SLA and our color jet printing. So the vat is full of a powder just like color jet printing, but it gets solidified with a laser just like SLA. The good thing is you can actually recycle the support material like with color jet printing. So you can actually make very large parts and cost effectively as well. So that's why this is actually being used for end-use applications nowadays, because you can actually get some very cost-effective parts that are durable, and you don't have to worry about what end user is using it because you know it's going to hold up just as well, and in some cases even better than injection molded products. So the actual material and material properties of these parts is the main selling point for these printers. You're going to be using end-use parts, or you need extremely durable prototypes to test pre-production, then this is what you want to look at. Highlights, again, durable parts, I can't say it enough. A wide range of manufacturing grade material. You can produce end-use parts, reusable support material, high throughput, affordable parts that you can actually do some production with. Limitations, it is, again, industrial machinery. Find feature limitations, so now we're back to, I mean, it has higher resolution than our color jet printing, but not as much as our SLA and multi-jet printing, right? So if you're looking for extremely high resolution, fine details, unfortunately SLS is not what you want to look at. You want to look at SLS when it's really, really tough parts, production quality parts, but really fine details, SLS is just not the one you want to look at. Again, industrial machinery is you know, something that you have facility requirements for. This is our line of SLS printers, again, all industrial grade stuff. These things, we have customers with these installed for a decade plus, they still work. So this is, you know, this is a capital investment that's going to last for you for a while. Now, direct metal printing, very, very similar to SLS. The only difference is, honestly, the strength of the laser that's being shot in there, and then also the material that it's shooting into, which is now, in this case, a powdered metal. So fundamentally the same as SLS. You have so you have a high-powered laser to image each layer. We have a roller that actually is unique to 3D Systems printer, which has a counter-rotation movement, which creates a 99.9 dense part. So this is actually produces parts that are actually more dense than cast and have better material properties than traditional cast parts. So if you were to get a cast part from a foundry and a 3D printed part off of a 3D printer, you're going to have better material properties in the 3D printed part. Now it's almost billet steel, so it's not quite like a machine part, so there is a slight limitation there. Also, you have biocompatible materials, so you do have titanium and cobalt chrome that you can print right off of this. You can implant it. It's pretty impressive stuff. So what are the high points? 18 different varieties of metal directly from 3D Systems. There is a third-party market out there that you can actually purchase a wider range of materials from. I don't recommend that. For 6 months or so, keep the 3D printed type material in there. I'm sorry, the 3D Systems type material in there. Once your technician knows how to use your system, then you can venture out into the other materials, and in all honesty, you have to talk to 3D Systems to help you get it catered to your printer. That's something, me saying as a reseller, you never heard it from 3D Systems directly, so don't hold me to it. The next thing is it is implantable. Complexity is free, right? So you can actually reduce weight significantly. This is a great aerospace application. You know, you can reduce the weight of a part by making it honeycomb. The added complexity is not going to be an issue in terms of cost. It'll actually save you money in terms of material. So now you can optimize the part for function as opposed to the limitation of the tool that you have. Also, it can create extremely complex patterns, just like you see on the hip replacement on the bottom left image. It has a very porous kind of sponge-like finish to it. That's to actually promote bone ingrowth. So that kind of complexity is actually free. Our customers, what they tend to do is, you know, the surface finish on direct metal printed parts slightly textured. If you need something that is extremely fine finished, you can then CNC machine off the little bit of the layer, so you can actually overgrow the part, then machine down certain features that you want. Again, industrial grade, requires accessories for post-processing, and the supports are not reusable, so it, you know, it's not as efficient as the color jet printing would be, or SLS. So this is our line of metal printers, ranging from a very small, basically 3-inch cube, all the way up to our DMP 320, which can actually produce a relatively large part. Actually, if you look at the watches there in the middle, that's the support material that's generated there. You would need equipment to remove the support material, but it is, you can basically snap it away with pliers. I've done it personally. So I think this is our last question, and we're wrapped. Oh, actually. actually I'm going to be asking two questions. So one is, are you currently budgeted? And then I'll quickly go into the last one because I know I'm up against the timeline right now. It's 3 p.m. Where I want to know which one of the technologies do you think is going to work for your applications. So we almost have everybody in, just a couple more people, and we will move on to the last poll question. And one last person, let's see if they can get in. Okay, all right, well, let's just close that out. I know I'm running up against the timeline here, so let me just go ahead and share that last question with you. So in this one, we're just trying to see, out of all the technologies that we covered today, which one's the one that you think would best apply to your applications. Good, okay, we're just missing one or two more people. Looks like the popular ones for this this segment is multi-jet printing and color jet printing. Cool. Okay, so now that's good to hear. So what we're going to be doing now is we're going to be taking a couple weeks break. Why? Because we're going to be walking around the Rapid show. We don't have a booth there. Our vendor, 3D Systems, will have a booth there. We will be at their booth intermittently, but we're going to make sure that our customers have the ability to go to Rapid without missing one of our webinars. And then May 27th, we're actually going to be covering our multi-jet printers in higher detail. Following that, we're going to get into SLA and SLS systems, then color jet printing May 13th, I'm sorry, the 13th of the following months, and then direct metal printing. So thank you very much, everybody, for joining us today. I really appreciate it. If you have any questions, feel free to email us, sales@wb-3d.com. You can go to our website to see our full line of 3D printers, and also you can just call us directly at our office line here. I don't see any other questions. If anybody has any questions, I'm here to, I can answer any questions. I can stay online for a couple more minutes. But in general, thank you very much. I appreciate your time. I will just stay online for a couple minutes just in case there's a couple of questions that we weren't able to get to. Okay, looks like no added questions. I did answer the questions that I did get via the chat, so thank you all very much. I appreciate your time and look forward to seeing you guys in the next webinar. Take care.